Hello students. Today we'll be discussing transformations between polar coordinates and Cartesian coordinates. This is a continuation from our previous video on polar coordinates, and this topic is meant for students currently taking or who will be taking AP Calculus BC. Let's look at an arbitrary point on the Cartesian coordinates here. So we can label this point in two ways, either with x and y for Cartesian or r and theta for polar. Let's start with going from r and theta to x and y. So if we draw a line from the point to the x-axis, you'll notice that we formed a right triangle. So since we have a right triangle, we can apply some trigonometry to get x and y in terms of r and theta. So if we do the math, we'll see that x is equal to r times the cosine of theta, while y is equal to r times the sine of theta. And you can solve this using simple trigonometry. Now with these two equations, we now have a way of going from polar to Cartesian. But what if we want to go the other way? Well, we can do that too. So if you notice, the tangent of theta here only depends on y and x. So let's write it down first. So tan theta is equal to y over x. So you'll notice that here theta only depends on x and y. So if we apply an arctangent, we'll arrive at, let's just rewrite this real quickly. Theta will become the inverse tangent, or the arctangent, of y over x. However, one thing to note is that the arctangent is bounded between negative pi over 2 and pi over 2. What this means is that if you're working in quadrants 2, 3, or 4, your answer is going to be off due to the bounds. So, to compensate for this, whenever your angle is in quadrant 2 or 3, you'll need to add pi to your answer. While, if your angle is in quadrant 4 here, you'll only need to add 2 pi to your answer. So that's it for theta. For r, you'll notice that in the right triangle here, we can apply Pythagorean theorem with r squared equals x squared plus y squared. That will give us r equals the square root of x squared plus y squared. And with these two equations, we'll be able to go from Cartesian to polar. That's it for this video. Thank you very much for watching. And in the next video, we'll be discussing transforming functions between Cartesian and polar.